Hey there. You ever feel like you're just drowning in headlines looking for something, substantial?
Definitely. Information overload is real.
Well, today we're diving deep into something pretty incredible. It might just be the strongest hint yet that we're not alone out there.
That's right. We're looking at this report about the James Webb Space Telescope, an amazing piece of tech.
And what it found looking at an exoplanet. So
Mhm.
our mission today, unpack the findings, figure out why it's such a big deal, but also, keep things grounded.
Exactly. Healthy skepticism is key in science.
Okay, let's get straight to it. This observation. The big news is finding specific gases around this planet,
Yeah.
K2-18b. But these aren't just like random atmospheric gases, are they?
No, not at all. They've found what looks like dimethyl sulfide, DMS, and maybe dimethyl disulfide, DMDS.
Okay, DMS rings a bell from Earth science, maybe?
It should. Here on Earth, DMS especially is overwhelmingly produced by life. We're talking tiny marine phytoplankton, other microbes.
Wow. So finding it out there, that's
That's the exciting part. It's what scientists call a potential biosignature, like finding a footprint. It suggests life might be present.
life, like actual living things, microscopic stuff, maybe.
Precisely. Think microbes, maybe something akin to our ocean plankton. That's the hypothesis these gases are hinting at.
But the report is careful, right? It's not saying we found aliens.
Absolutely not. Niku Matsuzuhan, the lead researcher from Cambridge, is very cautious. It's a potential sign. A very interesting one, but it needs much more work. No little green men confirmed.
Still, you can sort of feel the excitement, can't you? Madhusudan called it a transformational moment.
And in many ways it is. Just the fact we can detect these kinds of molecules hundreds of light years away, that's a huge leap forward technologically.
Yeah, it feels like we've suddenly got much sharper eyes on the universe.
That's a good way to put it.
So tell us about this place, K2-18b. Is it somewhere we could, visit?
Probably not anytime soon. It's quite a bit bigger than Earth. About 8.6 times the mass, 2.6 times the diameter, so significantly larger.
Okay, bigger. And where is it?
It's orbiting a red dwarf star. That's about 124 light years off in the constellation Leo. And it's not alone. There's at least one other planet we know of in that system.
Habitable zone, though. I think I read that. Around a red dwarf.
Yes, it's in the zone where temperatures could allow liquid water. But red dwarf systems are very different from ours. The star is cooler, dimmer.
And maybe more prone to flares? I've heard that can be rough for life.
That's a major consideration, yeah. Those flares could pose a challenge. So habitable zone doesn't automatically mean Earth-like.
Gotcha. Now, this term kept popping up in the report, Haitian world. What's that about?
Yes, Hyson worlds. It's a relatively new concept, a type of exoplanet scientists are thinking about.
Okay.
The idea is a planet with a massive liquid water ocean, maybe covering the whole surface, under a really thick atmosphere rich in hydrogen.
Hydrogen rich. That sounds
Yeah.
different.
Very different from early Earth. But the thinking is maybe life, particularly microbial life, could still find a way in such an environment. It broadens our horizons for where life might exist.
And K2-18b, it seems to fit this description.
It seems to, yes. Earlier, Webb data already showed methane and carbon dioxide there, which was a first, finding carbon molecules on a habitable zone planet.
Right, I remember that.
So, adding these potential DMS-DMDS detections, notices Hahn argues that the best explanation fitting all the data right now is a Haitian world.
A Haitian world. And he used the phrase teeming with life.
He did, which is strong language. But again, context is key. He's talking about microbial life, maybe like Earth's ocean life, potentially thriving in these perhaps quite warm, vast oceans.
Not complex creatures then, just microbes.
Based on this evidence, yes, that's the working hypothesis. Simple life forms.
Okay, back to the detection itself. DMS and DMDS. How sure are they? Is it a faint whisper or more solid?
Well, the report mentions a 99.7% confidence level for detecting at least one of them. In science, that's statistically significant, meaning it's unlikely to be just random noise.
99.7%. Pretty high.
It is, but still needs confirmation. What's also striking is the amount they seem to be detecting. Concentrations over 10 parts per million.
And how does that compare to Earth?
Madhusudhan points out it's thousands of times higher than the levels in Earth's atmosphere. That concentration makes a purely geological or chemical explanation, one without biology, quite difficult based on our current understanding.
Thousands of times higher. Okay, that's significant. It's not just a trace amount.
Exactly. It suggests, if it is biological, a potentially very active biosphere, perhaps very different from our own planet's overall activity level.
So how did Webb even sniff this out from so far away? It's incredible.
It is. They use something called the transit method. Basically, you watch the planet as it passes in front of its star. A tiny bit of the starlight filters through the planet's atmosphere on its way to the telescope. By analyzing which colors or wavelengths of light get absorbed or blocked by the atmosphere.
You can figure out what gases are in that atmosphere.
Precisely. It's like a chemical fingerprint encoded in the starlight.
Yeah.
And they mentioned using different instruments and wavelengths this time, confirming earlier fuzzier hints of DMS.
Clever. Okay, so super exciting results, high confidence, really high concentrations. But still, caution seems to be the watchword. Why the brakes?
Because science demands rigor, especially for a claim this big. Christopher Klein and other scientists mentioned really emphasize testing the data thoroughly. We need independent confirmation.
Right. Other teams looking at it.
Yes. And we also need to be absolutely sure there isn't some weird, unknown non-biological chemistry happening under the specific conditions of K2-18b that could mimic these signals. We think it's biology, but we need to rule out other possibilities.
Makes sense. You have to cover all the bases. So what are the next steps for Mathisatan's team? What do they do now?
Two main things, really. First, get more data. Observe K2-18b again, maybe 2 or 3 more times with Webb.
To make sure the signal is real and consistent.
Exactly. To boost the statistical confidence even higher, ideally making the chance of it being a fluke vanishingly small, like less than 1 in a million.
Okay. And the second thing?
More work back here on Earth. More theoretical modeling. More lab experiments trying to simulate K2-18b's conditions. Can they force chemistry to make DMS or DMDS without life under those specific pressures, temperatures, and atmospheric compositions?
Trying to prove themselves wrong, essentially.
In a way, yes. That's good science. You test your hypothesis rigorously. If it survives all attempts to disprove it, then you become much more confident.
It sounds incredibly thorough, which I guess it has to be for something this potentially huge.
Absolutely.
It really does circle back to that huge ancient question, doesn't it? Are we it? Is Earth the only place with life?
It's the big one. Madhusudan calls finding life signs on an Earth-like world the Holy Grail. And he even speculated we might be just a few years away from detecting possible life on one of these Haitian worlds.
Wow. A few years, that's soon in cosmic terms.
It feels incredibly close, doesn't it? But again, even he stresses that this finding for K2-18b is still a big if.
A big if. Compelling evidence, but not definitive proof yet.
Precisely. Intriguing, exciting, points in a fascinating direction, but the scientific process needs to continue. No jumping the gun.
Okay, so let's try and sum this up for everyone listening. We've got the James Webb Space Telescope detecting gases, specifically DMS and maybe DMDS, on exoplanet K2-18b.
Right.
And these gases, at least on Earth, are overwhelmingly produced by life.
Mainly microbial life.
The concentration seems really high, making non-biological explanations difficult but not impossible. And it fits this idea of a Haitian water world.
Correct. All the pieces seem to align with that potential picture.
But more observations and research are absolutely needed to confirm it. It's the strongest hint yet, maybe, but still a hint.
That's a very good summary. It's tantalizing science, pushing the boundaries of what we can detect, and forcing us to think about life in potentially very different environments.
It really gets the mind going. If this pans out, if life is confirmed out there, even just microbes, what does that mean for us, for humanity? What are the next questions we'd even ask? Something huge to chew on.
You'd change everything, wouldn't it? A profound shifting perspective.
Definitely something to think about. Well, thanks for diving into this with me today.
My pleasure. Fascinating stuff.